These are some of the most massive bursts of radio energy in the cosmos, emitting an amount of energy comparable to 1 billion suns. The intensity and radio frequencies generated by these bursts are so extreme that ultimately the entire universe will take notice of them. In breaking news from space, the James Webb Space Telescope, which provides us with profound insights into the universe's deepest mysteries, has uncovered something alarming. Betelgeuse, a star famed for its bright presence in our night sky, has exhibited signs of a potential supernova event in 2023. As we ponder the implications of such a celestial event, a startling revelation from the past surfaces. The enigmatic supernova SN 1987A. Could its secrets reveal crucial information about Betelgeuse's fate? What could this mean for our own planet? Join us as we delve into this cosmic enigma. The James Webb Space Telescope has been at the forefront of astronomical discoveries since its launch. Thanks to its advanced instruments and unmatched infrared capabilities, it has allowed us to explore the most distant regions of the universe, uncovering long-hidden secrets. One of its recent and alarming findings involves Betelgeuse and its possible supernova event in 2023. What has the JWST uncovered? Let's investigate. Before diving into the mysteries surrounding Betelgeuse, it's important to understand another monumental astronomical event, the explosion of SN 1987A. This supernova acts as a key reference point, offering valuable insights into the life cycles of massive stars and their dramatic ends. It helps us comprehend the behavior of stars like Betelgeuse. Recently, the telescope's near-infrared camera captured a detailed image of SN 1987A, revealing its complex structure. However, this supernova was first observed in 1987 when astronomers witnessed one of the brightest stellar explosions in the night sky. This explosion released a tremendous amount of energy, creating a brilliant flash of light visible from Earth. It remains one of the closest supernovae observed in centuries. Since its discovery, astronomers have been closely studying its expanding debris to better understand stellar evolution. SN 1987A, resulting from a giant star's explosive death, is located 168,000 light-years away in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. This supernova emits a broad spectrum of electromagnetic radiation from radio waves to gamma rays. It has been studied with renowned observatories like NASA's Hubble and Spitzer space telescopes and the Chandra X-ray Observatory. However, the James Webb Space Telescope has provided an unprecedented view of this iconic supernova. The telescope's near-infrared observations have captured the most detailed images of the supernova, showcasing its equatorial and outer rings, crescent-shaped inner ejecta, and unique keyhole structure. The center of the image displays dense gas and dust clusters expelled by the stellar explosion. This dust is so dense that even the near-infrared light from the JWST cannot penetrate it, resulting in the dark region in the keyhole. Surrounding the inner keyhole is a luminous equatorial ring formed by debris ejected tens of thousands of years before the supernova. This ring also contains glowing hotspots that developed when the supernova shock wave interacted with the ring structure. The JWST's sensitivity also revealed new crescent-shaped structures believed to be part of the supernova's outer gas layers. While neutron stars typically form after a supernova, the one in SN 1987A remains elusive due to its dense core. This explosion likely marks the death of a blue supergiant star, one of the most massive and luminous stars in the universe. As we have seen with SN 1987A, the universe is full of unpredictable phenomena. Now, Betelgeuse might be the next cosmic mystery to astonish us. Are we on the verge of witnessing another stellar event that could rival or even exceed the awe of SN 1987A? NASA astronomers are eagerly awaiting developments, having uncovered a revelation that has stirred the scientific community. Betelgeuse, known for its consistent brightness, has begun to dim, not gradually, but suddenly and noticeably. Observations from the JWST show that the star's brightness has significantly decreased in a short period. What could cause such a rapid dimming? Betelgeuse is no ordinary star. It is a colossal entity with a diameter about 900 times that of our Sun. If placed at the center of our solar system, its outer surface would extend beyond Jupiter's orbit. Massive stars like Betelgeuse have short lifespans and end their lives explosively, often resulting in supernovae. These explosive events are not only captivating but also crucial for the universe, as they distribute elements like carbon, nitrogen, and oxygen, essential building blocks for life as we know it. Essentially, the demise of stars like Betelgeuse contributes to the genesis of life elsewhere. Is it conceivable that a massive star like Betelgeuse could simply fade away without a dramatic end? The answer is both fascinating and intricate. Several theories have been proposed to explain this phenomenon. One prevalent theory suggests that dust clouds in front of the star are obscuring its light, leading to the observed dimming. As stars like Betelgeuse age, they often shed their outer layers, releasing substantial amounts of dust and gas into space. This material can create dense clouds that sometimes block the star's light, making it appear dimmer from our perspective. Recent observations indicate that Betelgeuse has been emitting increased amounts of material, resulting in such dust clouds. This process is a normal part of a star's life cycle, particularly for red supergiants like Betelgeuse. Another theory involves stellar pulsations. Massive stars such as Betelgeuse frequently undergo cycles of expansion and contraction. These pulsations can cause variations in brightness, with a star dimming during contraction phases. This behavior is not unusual for stars of Betelgeuse's type. The star's immense gravity pulls its outer layers inward, causing it to contract, while heat from the core pushes them outward, leading to expansion. This rhythmic pulsation can result in noticeable changes in brightness over short periods. However, the most concerning theory, which has garnered significant attention, is that this dimming might signal an impending supernova. Could we be on the verge of witnessing one of the most spectacular events in our cosmic neighborhood? The life cycle of a star is determined by its mass, and Betelgeuse, with a mass 20 times that of our Sun, is destined to end in a supernova. The sudden dimming might indicate that the star is depleting its fuel and is about to collapse under its own gravity. Historically, stars that have experienced sudden dimming have sometimes exploded in dramatic supernovae. These explosions are not only visually impressive but also play a vital role in the universe's evolution by dispersing essential elements into space. The JWST began observing Betelgeuse well before any potential supernova event, utilizing its suite of advanced instruments, including the near-infrared camera, the mid-infrared instrument, and the near-infrared spectrograph. The JWST gathered a wealth of data on Betelgeuse, capturing high-resolution images, analyzing the star's light spectrum, and detecting subtle changes in its brightness and temperature. Despite the sophisticated technology, how did the JWST detect changes in Betelgeuse leading up to a supernova? The data collected by the JWST is remarkable. For example, the mid-infrared instrument, MIRI, can observe in the mid-infrared spectrum and detect the heat emitted by the dust around Betelgeuse. This dust, resulting from the star shedding its outer layers, provides valuable information about the star's health and its impending demise. By analyzing this dust and the light emitted by Betelgeuse, astronomers can reconstruct the star's recent history, current state, and future prospects. Betelgeuse's mysterious nature has long captivated astronomers. Its sheer size and brightness make it stand out, but it's the surrounding mysteries that truly spark the imagination. Betelgeuse is a variable star, meaning its brightness fluctuates over time. While many stars exhibit this behavior, Betelgeuse's variations are particularly pronounced. These fluctuations have been observed for over a century, and though they were initially thought to be regular, recent observations have shown them to be more erratic. This unpredictability adds another layer of intrigue to this already enigmatic star. What causes these fluctuations? Betelgeuse, as a red supergiant, is a tumultuous environment of nuclear reactions deep within its core. Hydrogen atoms fuse to form helium, releasing vast amounts of energy. This energy pushes outward, causing the star's outer layers to expand. As these layers expand, they cool down, leading to a decrease in brightness. When the outer layers contract again, they heat up and increase the star's luminosity. This cycle of expansion and contraction results in the brightness variations we observe. Each pulsation of Betelgeuse offers astronomers a glimpse into its internal dynamics. By studying these pulsations, scientists can gain insights into the star's structure, composition, and future. For instance, have you ever wondered why stars have different colors? Why are some blue, others yellow, and some, like Betelgeuse, a brilliant red? The color of a star is directly related to its temperature. Blue stars are the hottest, with temperatures reaching up to 30,000 degrees Celsius, whereas red stars are cooler, with temperatures around 3,500 degrees Celsius. Betelgeuse, with its reddish hue, is considered a relatively cool star. But don't be deceived by the term cool. If you were to approach Betelgeuse, you would be incinerated long before getting close. Another intriguing aspect of Betelgeuse is its age. Although it may seem counterintuitive, massive stars like Betelgeuse have shorter lifespans than smaller stars. This is because they burn through their nuclear fuel much more quickly. Betelgeuse is nearing the end of its life and will ultimately explode as a supernova. This explosion will be so luminous that it will be visible even during the day, outshining all other stars in the night sky. The question everyone is asking is, when will this happen? Predicting the exact moment a star will go supernova is challenging, but the recent dimming event has led many to speculate that Betelgeuse's end might be closer than we think. Could we be witnessing the final days of this stellar giant? One key reason for believing that Betelgeuse might go supernova soon is its age and stage in the stellar life cycle. As previously mentioned, massive stars like Betelgeuse have shorter lifespans compared to smaller stars because they consume their nuclear fuel at an accelerated pace. Betelgeuse has already exhausted the hydrogen in its core and is now fusing heavier elements. Each successive fusion phase produces less energy and lasts for a shorter period. As the star fuses progressively heavier elements, it creates an onion-like structure with layers burning different elements. Once a massive star starts fusing iron in its core, it becomes a ticking time bomb. Iron fusion does not generate energy but consumes it, leading to a rapid collapse of the core followed by a rebounding shock wave that results in a supernova explosion. Another factor contributing to this belief is the star's pronounced dimming. Although dimming can be caused by several factors, such as dust clouds or stellar pulsations, the rapid and significant decrease in brightness might also indicate that the star is nearing the end of its life. Before a star goes supernova, it might shed a substantial portion of its outer layers, leading to such dimming events. If this supergiant were to explode, the event would be one of the most significant astronomical occurrences of our time. While the sheer spectacle would be awe-inspiring, the consequences of a Betelgeuse supernova would ripple across various domains, from immediate effects in space to long-term implications for our understanding of the universe. To begin with, let's imagine the immediate aftermath of the explosion. Betelgeuse going supernova would produce an intense burst of light, outshining every star in the night sky for weeks, possibly even months. This once familiar star would become a beacon in the sky, visible even during the day. The night sky would be transformed, with Betelgeuse's brilliance rivaling that of the full moon. This radiant display would captivate casual observers and offer a unique observational opportunity for astronomers worldwide. However, the light show is just the beginning. The energy released during the supernova would equal the total energy our sun will emit over its entire 10 billion-year lifetime. This explosion would send a shock wave hurtling through space, compressing and pushing the interstellar medium in its path. As this shock wave travels, it would heat up the surrounding gas, creating a glowing bubble of ionized material. This supernova remnant would continue to shine for thousands of years, serving as a lasting testament to Betelgeuse's explosive end. Beyond the immediate vicinity of the explosion, the supernova would emit a torrent of cosmic rays, high-energy particles traveling near the speed of light. These particles, primarily protons and atomic nuclei, would spread in all directions, with some eventually reaching our solar system. Although Earth's magnetic field and atmosphere would shield us from direct impacts, these particles could influence the solar wind, potentially enhancing auroras and making them visible at lower latitudes than usual. The explosion would also release a significant amount of gamma radiation, the most energetic form of electromagnetic radiation. Gamma rays can interact with other particles, producing electron-positron pairs. While most of this radiation would be absorbed by the interstellar medium, some might reach our solar system. Given Betelgeuse's distance from Earth, This radiation would not pose a direct threat, but would contribute to the background gamma radiation detected by satellites and space telescopes, providing valuable data for astrophysicists studying high-energy processes in the universe. On a deeper level, the materials ejected during the supernova would enrich the interstellar medium with heavy elements. Stars like Betelgeuse are cosmic forges where elements heavier than hydrogen and helium are synthesized. When such a star explodes, it disperses these elements into space. Elements like carbon, oxygen, nitrogen, and even metals like gold and platinum are spread throughout the cosmos, seeding it with the raw materials for future stars, planets, and possibly life. In a poetic sense, we owe our existence to the deaths of stars. The carbon in our cells, the oxygen we breathe, and the iron in our blood were all forged in the hearts of stars that exploded long before our solar system was born. Furthermore, the remnants of the explosion would offer a treasure trove of information about the life cycle of massive stars. By studying the layers of material ejected during the supernova, astronomers could piece together the star's history and understand the processes that occurred in its core during its final days. This would provide invaluable insights into stellar evolution, nuclear synthesis, and the dynamics of supernova explosions.